Hello students, welcome to the channel. In today's video, we'll look at an important math topic that is tested on ACT, polar coordinates. So what are polar coordinates? We know that the Cartesian coordinate system gives us the location of any point in terms of the x and y coordinates, right? So this is the x-axis and this is the y-axis. And let's say I have a point here. And let's say that my point is at 3, 3. So I know that its distance here is 3 and its distance here is also 3. And 3, 3 is called the Cartesian coordinates because they tell me the distance on the coordinate plane. Now, what is the distance of this point from the origin? Obviously, if I complete this triangle, this is a right triangle where the height is 3 and the base is 3. So by Pythagoras theorem, this distance, which is denoted by r, is 3 root 2, right? The distance of this point, let's call this point A from the origin, is 3 root 2. And what is this angle theta that the line joining this point to the origin makes with the positive x-axis? That would be tan theta is 3 by 3, opposite by base, which is 1. And we know that tan theta, when it's 1, theta is 45 degrees. So if you think about it, I can represent point A as 3 root 2, 45 degrees, because this gives me the distance of the point from the origin, and this gives me the inclination of the point with respect to the positive x-axis. And these coordinates are called polar coordinates, right? These are called polar coordinates. So if I have the Cartesian coordinates, then how do I convert them to polar coordinates? You can see that r will be under root of x squared plus y squared, because r is the hypotenuse of the triangle made up of x and y. And tan theta is y over x, right? Because here theta is just going to be the angle which the line r makes with the positive x-axis, right? Okay, what if I'm given polar coordinates and I have to convert them into Cartesian coordinates? So if you look at this distance, which is x, and this distance, which is y, then I can say that cos theta is x by r, cos theta is x by r, and sine theta is y by r by the notation of trigonometry. So x is r cos theta and y is r sine theta. So if you remember these rules, then it is very easy to convert a pair of Cartesian coordinates into a pair of polar coordinates. So let's try some sample problems. So in the standard xy coordinate plane below, P is on the positive x-axis. The measure of angle AOB is 150 degrees. So this is 150 degrees. And the length of AO is 1 coordinate unit. What are the coordinates of A, right? So we have to find the coordinates of A, x, y. So here R is 1 and theta is 150 degrees. So x is r cos theta, which is 1 times cos 150. Now we know that if we draw the trigonometric plane, 0, 90 degrees, 180 degrees, 270 degrees, and 360. We know that in the first quadrant between 0 and 90, all trigonometric ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive, right? So we know that. So just let me move this to the left. Wait, what did I do here? Did I shift something? Okay. Yeah, I think I moved the whole thing to the, yeah, this is fine now. Okay. So what I notice here is that 150 is in the second quadrant. So sine will be positive, but cos would be negative. So cos 150, which is cos of 180 minus 30, will be negative cos 30, right? And what is cos 30? Cos 30 is root 3 by 2. So this would be negative root 3 by 2. So x will be negative root 3 by 2. And y will be r sine theta, which is 1 times sine 150. And we know that sine is positive in the second quadrant. So sine 150 is sine 180 minus 30, which is positive sine 30, which is plus half. So this would be plus half. So the xy coordinates of this point would be minus root 3 by 2, comma 1 by 2, which is option F, minus root 3 by 2, comma 1 by 2. So you see, I used the concept of theta and r to convert those polar coordinates into Cartesian coordinates. And I also use the concept of trigonometric angles and their trigonometric ratios in terms of the quadrant. So if I'm working between 0 and 90 degrees, the first quadrant, then all the trigonometric ratios are positive and so on. So this ASTC rule, which we have discussed in the trigonometry video, is important to remember when you're doing polar coordinates questions. Okay, let's try another question. Which of the following polar coordinates represents the same location as 3, 45 degrees? Now, if you look at 3, 45 degrees, then this distance is 3 and this distance is 45 degrees. So you're basically saying that the x coordinate is 3 cos 45 and the y coordinate is 3 sine 45. And you know that this lies in the first quadrant. Now, when will this point happen again? If I start and I come back to this like this, right? Which is to say that if I go all the way around and come back to this line by adding 360 degrees to 45, right? Because that would be 405. So I would notice that cos of 405 and sine of 405 will have the same location as cos of 45 and sine of 45. Correct? But what about these options? What about these options? Let me look at these options now. So if I look at option A, I have 3 cos minus 315 and 3 sine minus 315. Correct? Now, if you look at cos of negative theta, that's just cos theta, and sine of negative theta is minus sine theta. So this is the same as 3 cos 315 and minus 3 sine 315. Correct? Now, what about 315? 315 is 360 minus 45, right? It's 360 minus 45. So this would be 3 cos 360 minus 45 and minus 3 sine 360 minus 45. Now we are looking at 315. 315 is going to be here. So I'm just going to remove what I explained earlier. Yeah. So this, and I'm going to change the color. This angle is 315 degrees. So if we use ASTC, I know that in this quadrant, in the fourth quadrant, cos is positive. So when I write, one second. Yeah, so when I write 3, when I write 3 cos 360 minus 45, that's just 3 cos 45, right? And that is what I wanted for x. So x is no problem. When I write, let me clear this as well. And when I write minus 3 sine 360 minus 45, then I notice that sine of 360 minus 45 will be nothing but minus sine 45, right? Because in the fourth quadrant, sine is negative. So this will be minus 3 multiplied by minus sine 45, which is plus 3 sine 45. And that's exactly what I had for the y coordinate. So I noticed that the right answer is actually option A, because in the case of this option, I have the same location for the function or for the coordinates as I had for 3, 45. And how did I get that? I got that by using the concept of ASTC, by using the concept of cos and sine, and working on those angles to see how you can get the final angle with respect to the initial angle. Hope this exercise was useful. If it was, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload. I'll see you guys in a new video soon. Take care. Bye-bye.